So welcome everyone to creating accessible native apps at React Native, React Summit rather. So we'll be covering quite a few topics today. So I'll try to move quickly in order to make room for some of the questions at the end. So as Liam said, my name is Scott Vinkle. I am one of two accessibility specialists at Shopify. So this means I work with a lot of teams. I do a lot of testing with assistive technology, and I write a lot of accessibility issue tickets on GitHub. So you can find me at svinkle on Twitter, or my blog and online store is at scottvinkle.me. In my spare time, I like to ride my bike when the weather is nice, read books, watch movies, and spend time with my family. And my two kids definitely keep me busy, especially during these COVID days. So back in January of 2020, seems like forever ago, Shopify publicly announced our adoption of React Native. This meant that from this point forward, all of our new mobile apps would be built with React Native. By extension, this also meant that learning a new learning opportunity for our accessibility team by way of testing apps and guiding design and development teams to create accessible user experiences. Fast forward a few months, a few volunteers from Shopify start working on a new React Native app called COVID Shield. Now, COVID Shield is a COVID-19 exposure notification solution, which uses the exposure technologies provided by Apple and Google. While the team at Shopify was working on the app, I was contacted by one of the leads and brought onto the team to conduct a bunch of accessibility testing as development was taking place. So what I'll be covering today includes details on how I tested the COVID Shield app for accessibility, some of the more interesting issues that I found, and the related solutions to those issues. Before I do that, it's worth noting that COVID Shield was eventually adopted by the Canadian federal government to provide Canadian citizens a notification method for potential exposure to COVID-19. It was rebranded as COVID Alert, and development was taken over by the Canadian Digital Services team. So I definitely recommend installing this app if you are a Canadian citizen. So what I'll be covering today includes details on how I tested the COVID Shield app for accessibility, some issues I found, and the related solutions. Before we get into those details, we'll cover some other important topics around accessibility out of a general state. So some of the topics we'll discuss include: what is digital accessibility? Who are we including when we talk about accessibility? What assistive technologies are available? How to test using mobile devices and simulators? And then finally, I'll review some React Native specifics, that is, issues I found when testing COVID Shield. And at the end, we'll have some time for questions. So to start us off, what is digital accessibility? It's a good question. I'm glad you asked. Simply put, digital accessibility means building digital content and applications that can be used by people with disabilities. So these techniques can and should be applied to websites, mobile apps, desktop apps, operating systems, video games, electronic documents like PDFs, kiosks, and a whole lot more. From some statistics from the Global 2020 Economics of Disability annual report, there's an estimated 1.85 billion people who identify as having a disability. So this number does not include those who do not identify with having a disability. So the total number could actually be higher. This actually makes up an emerging market larger than China. The disability market influences over 13 trillion in annual disposable income. So there's some serious spending power there, which should not be ignored. And of course, as the world population grows, so do the number of people with disabilities, as well as the total amount of disposable income. So keep those numbers in mind. So who exactly are we talking about when we say we need to make our digital products accessible? Well, people with disabilities. So there are many types of disabilities which need to be taken into consideration when creating digital content. At a high level, some disabilities include visual impairments, so people with low vision, color blindness, or who are blind; hearing impairments, people who are deaf or hard of hearing; cognitive impairments, people who may have difficulties processing or understanding information; and motor impairments, people with a physical disability. So these represent only a few disabilities that are at a very generalized level. There are many more than this, including other permanent disabilities, But we shouldn't forget about the temporary or situational disabilities, such as someone with a broken arm. It's also important to note that someone could have one or a combination of disabilities. So, for example, someone with a motor impairment who uses a wheelchair could also have a cognitive disability. And also note that disability is not binary, meaning it isn't always all or nothing. So someone who's blind may still have some vision. They could be able to see just enough to play a video game with accessibility options enabled, for example. Or a wheelchair user could still be able to walk very short distances, but it could be very difficult or even painful. Thus, they rely on their wheelchair to live more independently. So how do people with disabilities use technology to consume our digital content? Let's explore. So disabled people consume digital content by way of assistive technology. There are a number of assistive technologies and devices available to people with disabilities, some of which include, but are not limited to, screen readers, which audibly read out content to the user. This allows the user to navigate via keyboard and keyboard shortcuts. So when the user is navigating and consuming content via screen reader, this is what's referred to as the oral or audible user experience, as opposed to the visual user experience. Keyboard-only users are people who can't use a mouse due to visual or motor impairments. As a result, they need to be able to navigate entirely by keyboard. Likewise, alternative input devices such as sip and puff or single switch buttons emulate keyboard-style input. Screen magnification software or hardware tools help by magnifying the screen to extreme levels for people with low vision. Another example here, voice dictation software allows people who are unable to use a mouse and keyboard to navigate by voice command. So there are many more forms of assistive technology input methods. These are just a few examples. So far we've covered people with disabilities are able to use modern technology via assistive technology, and the fact that there is a large market share available by creating more inclusive experiences. So what this comes down to is people with disabilities have the right to access goods and services, both in the physical and digital world. They want to feel included, connected, and just find their place in the general community. I really like this quote from Annie Jean-Baptiste, head of product inclusion at Google and the author of the book, Building for Everyone. We need to build for everyone, with everyone, not only because it is the right thing to do, but also because it drives innovation and growth while making the world a better, richer place. I'm still reading this book, but it's a really great book. I highly recommend it. So we know people with disabilities are able to use technology to browse the web on desktop and mobile devices, etc. So the question now is, how do we as designers and developers of the web and native mobile apps make sure our products are usable by everyone? In other words, how do we make things accessible? By testing, of course, testing all the things and knowing what to watch for, right? That's the key. So understanding how to test with assistive technology and expectations from people with disabilities when interacting with content is a big part of creating usable and accessible experiences. Knowing if something is accessible can generally be summarized in these three questions. And shout out to Derek Featherstone, Feather on Twitter, for sharing these questions on a Twitter thread a little while back. So first, when someone is working and using your app, they might ask the question, what is this thing? So when someone encounters something on the screen, it could be a form field, a link, a button, an image, there needs to be information included to share context and understanding of what the thing is they're currently interacting with. So this information comes in the form of the element's semantic meaning and programmatic details added by the developer. Semantics are made up of the element role, name, and state. So the name, also known as the accessible name or label, is the part that describes what the element is for, its purpose of being. In terms of HTML, this is found as the content between the start and end tags of the element. It could also be the alternative text value for an image the alt attribute, or the label associated with a form input. So let's take, for instance, a link. This element has text between its start and end tag. This text gets read aloud by a screen reader, and when it receives keyboard focus, it conveys the context of what the link is for. So for example, a link in a navigation area with the accessible name of Contact Us might indicate it would load a new page with some contact information. The element's role informs the user of a few things, including what the element is and how to interact with it. Various element roles come with expectations on how to use or interact with them. Depending on the role, a user might expect they would need to press the Enter key to continue, use the space key to activate a button in a form, or perhaps use the up and down arrow keys to make a selection when interacting with a select element. Just going back to the link example, the role announced when the link receives keyboard focus would be link, as links are structured with the opening and closing A tags and included in a valid href attribute. So the expected result, or what it does, would be for the browser to either load a new page or jump to another section of the same page. How to interact with the link would be for the user to press the Enter key, as this is also part of the semantic meaning. And in addition to the accessible name and role, depending on the element at hand, there could also be a state announcement. So announcing the state helps to convey the current condition of the element, whether interaction is needed, and what might happen when interaction takes place. So for example, checkboxes and radio buttons have checked or unchecked and selected or unselected state, respectively. So the second question, what happens when I click this thing, right? For the oral user experience, this is typically discerned from the previous question, the role, name, and state. So affordances or hints as to what might happen on click are based on the visual and oral user experiences. So for example, clicking an interactive control with the link role and the name read more about knitting will likely open a new page, content about knitting, right? Clicking an interactive control with a checkbox role and the name subscribe to our newsletter would probably check the checkbox and enable this option when submitting a form. So these details, the semantics of the control in question, which supplies the oral experience, as well as the visual affordances, provide hints to the user to what may happen when they click the control. So it's not only important to design the elements on the screen to look like the thing they are, but also by providing programmatic context via semantic meaning. So this leads to the final question. Did clicking the thing meet my expectations? This is a big one. So in other words, did activating the control result in what the user had in mind for when they clicked? Was the user successful or not? So for example, did clicking the search button result in a search results page being loaded, indicating how many items there were returned? Did clicking play on a button result in playback of a video? All right. So being able to meet the user's expectations is very important in helping the user feel successful. Without this feeling of being successful, self-doubt inevitably sinks in. So the user may start to question the quality of the app they're using, or blame themselves for not understanding how to use the app. So neither case is desirable. So what we want to do is help guide our users to success and feel comfortable and confident when using our apps. So the point is, if all of these three conditions are met, 1, understanding what the thing is, 2, knowing what's expected when the thing is clicked, and 3, having user expectations met as a result, if all of these were answered in the affirmative, it's a pretty good indicator that the thing is accessible. So at a high level, here's here's a big list of other things and their expected results. And I think due to time, I'm going to skip this one, but you have the notes there, and yeah, we can come back to that. So here's the thing. A lot of these expectations are derived from the Web Content Accessibility Guidelines, or WCAG for short. WCAG is a worldwide recognized standard for testing and implementing accessible and inclusive user experiences. It's primarily used for desktop and mobile web, but it can also be used for native apps and pretty much any other type of digital content. So the basis of technical accessibility recommendations are derived from one of the 4 principles of accessibility. Each principle represents a set of guidelines which are to be followed in order to create a usable and accessible experience. So at a high level, the principles include perceivable. Can the user identify information and relationships of content? Operable. Can the user interact with content? Understandable. Can the user understand the content available to them? And robust. Does the site or app work consistently with the user's technologies? Is it built in a way that will continue to work with browsers and assistive technologies moving forward? And if you're looking for a checklist resource to work with through as you test your site or app, I'd recommend the checklist from the A11Y project. I contributed a lot of the content to this list, and it's basically what I use internally at Shopify. So the URL for this is a11yproject.com/checklist. Okay, that's a lot of information. So let's get to it. This is part of the workshop where you get to do something. So I want to take everyone through enabling the screen reader available to them on their mobile platform. So I'm making the assumption here that you are either on iOS or Android, but I feel like that's a pretty safe assumption these days. So in terms of React Native, these few tips will be useful for when you've got your app up and running on your real device. But we'll cover how to test in simulators shortly. So we'll start small by going through the steps of turning the screen reader on and then off. You'll see in a second that once the screen reader is enabled, how different you're using your device can be. It's a very different experience than what you might be used to. So here's the thing. Before we start, it's important to understand the basics of using a mobile screen reader. Otherwise, you may get stuck and not know how to return to the previous state. So both iOS and Android feature a similar base set of gestures when it comes to navigation. That is, finding and activating a control on the screen. There are 2 basic methods here. One, explore. So what you'd want to do is place a single finger anywhere on the screen and drag it around in order to discover content. This will cause the screen reader to announce the item which is currently under your finger. So you are free to explore in any direction using this method. And the other method, called swipe, use a single finger and swipe right anywhere on the screen. This allows the screen reader to locate and announce content items on the screen from a top to bottom, left to right sequence. Swiping left will find items in the reverse order. So once a piece of content is in screen reader focus, you can double tap anywhere on the screen to activate it. This is important to remember, especially when attempting to disable the screen reader afterwards. So if folks here are on iOS, as well as iPadOS, these devices come with a screen reader called VoiceOver. So side tip, if you're testing a site in a mobile browser, typical pairing would be with Safari. So to enable VoiceOver on your iOS device, you go to Settings, Accessibility, and then click the VoiceOver switch control. So this is awkward because normally I would be able to see folks who are attending my workshop, but since I can't, I don't know what is happening. I'll give you a few minutes to sort of try that out. Also, if you have the slides here, you can sort of flip back and between slides. So if you're successful in enabling VoiceOver and you'd like to turn it off, remember to use a single finger and drag to the VoiceOver switch. Focus on this control and then double tap. In order to save time while you're testing, you can set up your device with a shortcut for turning VoiceOver on and off. So to activate this feature, you can go to Settings, General, Accessibility, and Accessibility Shortcut. So with this enabled, you can now turn on VoiceOver on and off by triple pressing the iPhone or iPad home button.
Scott, could you just quickly go through the previous slide with the navigation methods? I think maybe 1 or 2 people might not have caught that.
Sure.
Just around those 2 navigation methods. Sure.
Yeah. Yeah. So the idea is actually I was going to I can demonstrate this, the basic methods here. So you can lock my phone.
Talk back on.
So I'm using Android.
Oh, button.
I probably can't see my phone very well because the slides are up anyway. I can just slide my finger.
Connection is secure. Remote.react zoom in. 8 open tabs. Tap.
And it'll find things.
React under.
Or I can click and drag my finger. Maybe. Actually, this is the React Summit site. I don't know how well it works. Okay, maybe there's problems.
React _ summit _ online.
Okay.
Link.
Anyway,
Double tap to activate.
That's the general idea. So yeah, so that's the general idea. I'm going to skip ahead to folks who are on Android and go through the steps for Android. Yeah, so for Android, most Android devices, not necessarily all, but most of them come with a screen reader called TalkBack. So if your device does not have this available, you can install it from the Android Accessibility Suite, which is available on the Google Play Store. So starting TalkBack may differ slightly depending on the Android phone manufacturer. So for Google Pixel devices, you can go to Settings, Accessibility, and then click on Use TalkBack Switch Control. And in order to save time while testing, you can set up your device with a shortcut for turning TalkBack on and off. So to activate this feature, you can go to Settings, Accessibility, TalkBack, and then TalkBack Shortcut. So with this enabled, you can now turn TalkBack on and off by pressing and holding both volume keys at the same time. I'll go through some more common gestures between the two environments. And again, you can sort of flip back and forth between the slides if you have them available to review. So for iOS users, while you're testing with VoiceOver, here are some common gestures. So to select and read the current item, you can touch or a single tap. Activate the currently selected item, double tap. Move to the next item is a swipe right. Move to the previous item is swipe left. Pause or resume reading is a 2-finger tap. Scrolling up is a 3-finger swipe up. That's just on a general screen. Scrolling down is a 3-finger swipe down. So again, there are a lot more gestures available than these, but these would be common, I would say, in conducting simple testing. And then for Android users, here's some more common gestures. So selecting or reading the item is a touch or a single tap. Activating the current selected item is a double tap. Moving to the next item is swipe right. Moving to the previous item is a swipe left. And scrolling up in this case is only a 2-finger gesture of sliding up. And scrolling down is a 2-finger gesture of sliding down. So while you're giving that a try, I really recommend trying it on something maybe that you're working on. So maybe you're at a company and you're creating an app. Load up the app on your device if you can and give it a try. It's really interesting what you might find. This is actually basically how I got into accessibility. It was actually 10 years ago, I realized. I was working on a site at an agency one time, and I'd always heard of a screen reader. I never knew really what it was, but for some reason that day I decided to do Google search and figure it out. So of course, one of the first screen readers that people often find is ChromeVox, which is an extension for Chrome. So I fired it up on one of the sites that I was working on and just started talking back to me, like the site that I was actively developing. And it sort of blew my mind. Like this realization that 1, this technology existed, and 2, people rely on this technology every day to sort of, help them read content on the web. Sort of was a really big eye opener. And it's been my main focus for the last 10 years, accessibility in development and design. Okay, so let's continue. I actually have a lot of content here. So let's keep going here. Yeah, so testing on real world devices is great when your app is in good state to do so, but ideally You'd also be testing as you're developing the app. So let's go over what testing methods are available when you're working on your app on an iOS simulator or an Android emulator on the desktop. So one method of testing your app in the simulator is the macOS Accessibility Inspector. So the Accessibility Inspector is a tool much like a web inspector found in any modern browser. So you can use it to inspect specific pieces of the UI to test for things like component label, role, or state. It basically shows you how a particular part of your app may sound when a screen reader is in use by outputting this data to the window. So there are two methods to open the Accessibility Inspector. One is going through Xcode, and then Open Developer Tool, and then Accessibility Inspector. Or the other method is to simply use Spotlight Search on macOS desktop and type Accessibility Inspector. To use the inspector, you'd click the crosshair icon and then use the mouse to hover over the UI to be tested. And there's a lot of useful information in the basic section of the Accessibility Inspector window, such as the component role and name. For more advanced information, like the component state, you'll need to open up the advanced section of the window. So for the example here in the screenshot, I was inspecting a button control on the COVID Shield app, which would show and hide the main navigation menu. The label in the Accessibility Inspector revealed that the button's accessible name included everything in the navigation window. So that was an issue to be addressed. And the other way to test your app while in active development is by using the macOS VoiceOver on your desktop. So while VoiceOver is not available directly on the Xcode simulator, it is actually possible to run VoiceOver from macOS to test your app. So to do this, you set your keyboard focus onto the simulator window and then enable and disable VoiceOver with Command F5. So from here, you'll be able to use the virtual cursor to move between items on the screen. So to do this, to move the virtual cursor, you press Control, Option, and then left or right arrows to move between content items. So in order to interact with clickable items on the app, you press Control, Option, and then the space key. You can also test using gestures in the simulator, which is pretty neat. You can pinch zoom, and swipe in the iOS simulator by holding the Option key and then clicking and dragging your mouse cursor. So testing with VoiceOver on the desktop, as well as using Accessibility Inspector, this allows you to hear what the UI sounds like, that is, the oral experience. So while you're testing and going through various aspects of your UI, remember the three questions. What is this thing? What happens when I click? And were my expectations met? So let's switch back over to Android and testing in the Android emulator. So if your native app is running in the Android emulator, you can run the TalkBack screen reader directly in the emulator for testing. However, TalkBack is not installed by default. So you can install TalkBack by logging into your Google account in the emulator and install the Android Accessibility Suite from Google Play. So refer back a few slides for more details, but as a reminder, starting TalkBack may differ slightly depending on the Android simulator in use. So for Google Pixel-based simulators, you go to Settings, Accessibility, and then click the Use TalkBack switch control. There's a few ways you can use TalkBack in the emulator. So one is you can pinch, zoom, and swipe in the Android emulator by clicking the Command key and dragging your mouse cursor. And then content discovery can be done in one of two ways, which is to use the mouse pointer to click and hold, and drag around on the screen. So this is the same as using Explore method on an actual device, as we've already discussed. And then the other way is to use the mouse to swipe through the content. So I found this only works some of the times. It's kind of cumbersome than on an actual device, and it may lead to unexpected results. So if you can, it's actually better to test on a real world device. Oh, this is something I found out recently. So in the AVD, make sure to test with a device image that comes with the Play Store app installed, because not all of them do. Okay, so how are we doing on time? We're doing okay. So far we've learned what to watch for in terms of identifying accessibility issues. That is the three questions. What is this thing? What happens when I click? And were my expectations met? We also learned how to test with mobile screen readers in iOS and Android devices, as well as discuss basic testing within the iOS simulator and the Android emulator while working with our apps. So how does all of this come to play for React Native? If I've identified an accessibility issue, how do I go about fixing the issue? Well, to remedy any accessibility issues you may find, almost any accessibility issues, Facebook has actually put together this really great React Native accessibility API. So the API includes a series of React methods and props to provide things like roles, state, and name to interactive elements. It also includes other items to increase general usability of an app while using assistive technology. So we'll look at some of these shortly, but I want to point out that if you're at all familiar with things like HTML, the DOM, the area spec, then you've got a good head start on using the accessibility API. So concepts such as adding a role to an element to provide a semantic meaning, setting a label and a control via area label, or hiding something completely with area hidden, these are all possible with this API. It's just slightly different. The API documentation is available at reactnative.dev/docs/accessibility. So during my time working on the COVID Shield, I didn't have a chance to explore all of the API, but I'll go through what I did discover and share those the issues with you. So let's start with a theme that we've discussed a few times already, adding a role, name, and state to clickable elements, such as a button. So in developing for the web, authors have a few native clickable elements in which to work with, to request data or to show a new view, links, and buttons. So these elements come with their respective semantics shared via their role, name, and state, if it's applicable. So I noticed that React Native provides a generic button component. It outputs markup, which is similar to the HTML button element. This is good when loading a new view into the app or for other interactions such as submitting a form. However, there doesn't seem to be, at least I couldn't find anything for a concept to convey a link, which is the case in the case of a native app. A link might exit the app and load the mobile browser with a new resource. So not having a link type is unfortunate, as folks may end up adding a custom link style to with an on-press prop to a generic text component. So the issue here is that this is basically creating the equivalent of a span with an on-click event in HTML. So this creates an accessibility barrier, as there be no role applied to indicate what the thing was, as well as not being focusable. So in my experience with COVID Shield, the team decided on a different approach. In order to make the app appear more native for each platform, there was a custom button component that was created for use within the app. So this component included some logic to generate platform-specific touch controls. So for example, iOS devices would receive the touchable opacity component, and Android devices would use the ripple component, which was imported from the React Native Material Ripple package. So the issue I found with these components was that they did not include a role to help convey what the thing was, right? What was interesting is I noticed while testing that only TalkBack on Android still announced the control as clickable, and it also said double tap to activate. So I'm assuming this could be due to the fact that there's an on-press prop added, but it still does not actually communicate what the control is via its role. So let's review how to add a role in React Native. So while I was testing with a screen reader on either platform, Android or iOS, I noticed throughout the app that each clickable interactive control was missing its role description. So the screen reader would stop on the control and only announce its name if one existed. So as a sighted user, I had the visual affordance, that is the design of the button, to indicate that this was a clickable control. But as a screen reader user, they might not likely be able to tell what they're currently focused on. So in React Native, adding a role to provide context on the current thing the user is interacting with is a matter of adding the accessibility role prop. So you'd add this to the component which receives the click event. So this prop takes a string value, which is defined in the API. So one of which is the value of button, which denotes an action will result upon activation. So in HTML, this is similar to adding the role attribute to an element and assigning its role, assigning the value of a button. So for example, the screenshot here shows the COVID shield with a visually styled button with the name enter code. Without the explicit role declaration, I believe there was only like some sort of blip, like sound, when the control came into focus by the screen reader, but nothing more to indicate what the thing actually was. And after adding the accessibility role prop, after adding the accessibility role prop with the value of button, the control was then described as enter code button. So again, the purpose of this is to alert the user that they're currently focused on an interactive control, and the button value helps to give a clue to what might happen upon interaction. So in this case, load a new view onto the screen. So another issue I noticed while testing, there were a few clickable elements in the view that only used icons to provide a visual affordance. So not only were these controls missing their role, they were also missing an accessible name to provide details on what they were meant for. The screen reader would stop on the control and not announce anything. Again, as a sighted user, I had the visual affordance of the icon indicating the control's purpose. But without a role and name, a screen reader user would experience a seemingly unnecessarily tab stop. Probably quite a confusing experience to say the least. So in React Native, adding a name or a label to provide a sense of purpose for the current thing the user is interacting with is a matter of including accessibility label prop. So this prop takes a string value, which is defined by the author. So be sure to include something that makes sense and is appropriate for the context. So in HTML, this is similar to adding the area label attribute to an element and assigning it an accessible name for screen readers to announce. So in the screenshot here, I've highlighted an icon control with a downward pointing arrow. This is meant as an indicator that this portion of the screen is collapsible. However, since there was no label or a role, the screen reader would stop on the control and not provide any information. And after adding the explicit name and role, the control would then be announced as close button. So with this, the user would have more of an understanding of what the control's purpose was and be able to act on it accordingly. So testing around the COVID Shield app, there were some instances where controls were in a specific state. In one view, there was a list of checked or unchecked items. And in another, there was a form with a submit control in a disabled state by default. And I knew these things because as a sighted user, they were communicated to me by the visual affordance of the design. Now, again, as a screener user, however, they would not be able to acquire such information via the RL user experience. Nothing was added programmatically to provide information towards the control's current state. So we definitely want to include this information. So in React Native, we can add a state by providing, by adding the accessibility state prop. So this prop takes an object, which its definition and values are defined by the API. So in HTML, this would be similar to adding one of the many area state attributes. For example, adding area disabled to convey a disabled state of a form control, or area selected to convey the state of a tab control. So in the screenshot here, I've highlighted a form submit control with the label submit code. It's visually grayed out, indicating its disabled state. However, since there was no explicit state provided, the screen reader would stop on the control and announce its name only. After adding the explicit state object and role, the control would be announced as submit code dimmed button. And in this particular example, the word dimmed is actually unique to iOS. Android describes this state as disabled. Okay, moving on here, let's talk about headings. So that is headings referring to typically a large, bold text, which denotes the title of a page or a new section of content. So when testing COVID Shield, I noticed there were instances of larger, bold text that would appear throughout the app, usually at the top of a new view. In essence, the design visually conveys the presence and structure of a heading, but the oral experience did not. So you may be asking why is this important? So here's why. It's important because when someone who depends on assistive technology, such as a screen reader, visits a new site, page, or app that they've never been to before, they'll often first navigate by headings. Screen readers have the functionality to allow the user to navigate by only a specific type of content. For example, only links or only buttons, images, or maybe tables or lists, etc. So specifically, people navigate by headings first in order to quickly get a sense of the content being offered on the page. So it's the same idea of someone scanning through and reading the headings of a newspaper or a blog post. The idea is to gather the general idea of the content available to them and then revisit the sections of interest. So how do we actually add a heading in React Native? So we can indicate a heading by adding the accessibility role prop to the component which contains the heading text. And according to the React Native Accessibility API, the string value of header, that is HEADER, not heading, should be supplied to the accessibility role prop. So in HTML, this is actually similar to adding the role equals heading attribute to a text element, but really it'd be best to use one of the native heading elements, H1 through H6. It's also interesting that I noticed React Native, they don't have the ability to assign a heading level. So in HTML, we have the H1 through H6 heading elements, which indicate the heading level and logical structure of the content. But with React Native, it's strictly a heading only. So I'd say this is a better user experience than the no heading structure at all. So for the example here, the screenshot shows COVID Shield with a visually styled text heading with the content, share your random IDs. Without the explicit heading declaration, the screen reader would read the content as plain text. So it's not the worst experience in the world, but it's also not conveying the same experience as a sighted user would receive. That is the large, bold typography indicating a new section of content. So after adding the accessibility role prop with the appropriate header value, the text was then described as share your random IDs heading. Again, not only is the oral user experience describing the text as a heading denoting a new section of content, but screen readers users can also navigate via headings alone in order to gain an understanding of the content on the page. So this is a really great example of a quick accessibility win, right? Low effort, resulting in high impact. So let's discuss the concept of hint text. So hint text, in the context of where I'll be using it, is a method to provide additional information that is visually hidden from sighted users. So for example, if there is a visual indicator such as an icon, which conveys meaning to sighted users, we also need to pass these details along for folks who may not be able to see the visual hint. And this situation actually did come up while testing COVID Shield, when a couple of items on the main menu would open the device web browser instead of loading a new view inside the app. And this scenario is actually quite common on the web. So the idea is if a link opens a new browser tab or window, or if the app control takes the user out of the current app, it's actually best practice to inform the user of this end result. So why is this important? Without this context, people might believe they're following an internal site or app link, which loads in the same browser window or app. Opening a new tab or the device browser on behalf of the user would cause extra work for sighted keyboard-only users, screen reader users, or voice dictation users. If they're unprepared to move away from the current site or app, they need to put in the extra effort to switch back to the previous tab. So the idea is to give power to the user, right? Inform the user of what might happen upon interaction, and in order to allow a decision to be made on how and when they'd like to proceed. So we can include hint text by adding the accessibility hint prop to the component, which activation results in the new context being opened. So this prop takes a string value, which is defined by the author. So be sure to include something that's appropriate for the context of the control. So in this case, typically something along the lines of opens in a new window provides the context required to alert the user. In HTML, this is actually similar to adding the upcoming but not yet available area description attribute. And there's a link in the notes there. You can read more about that. So for this example, the screenshot shows the COVID Shield menu highlighting a clickable control with the content check symptoms. Beside the text is an arrow icon pointing up and to the right. So the intention here is to provide a visual indication of the activation result, that is leaving the app and entering a different context. So without the accessibility hint prop, the control simply reads check symptoms. Now, after reading the accessibility hint and the accessibility role, with the hint text value, the control was then described as check symptoms, opens in a new window, link. All right. So not only is the visual user experience increased by the icon, now the oral user experience is also enhanced by sharing the meaning behind the icon. As a result, all users will be able to make an informed decision if and when to activate the link, either now or later when they're ready. So next, let's talk about a topic that's actually quite critical to the success of your app in terms of accessibility. That is focus management. So focus management is a method to willfully and purposefully shift the keyboard focus cursor from one element to another on behalf of the user. So this technique is sometimes required to guide the user with the intended flow of the app. So for example, when opening a modal window, focus must be placed on or inside of the modal window in order to bring this new context awareness to the user. Otherwise, focus remains on the activator control, and the user may not be aware or be able to reach the modal content. Focus management should only be used when absolutely necessary, as to not create more work for the user when an unexpected shift in focus has occurred. So, in terms of COVID Shield, React Native, and basically any single page app, a big accessibility issue lies in managing focus between views. So in a traditional browser environment, the user could click a link or a button to submit a form, and a full page refresh would occur. So at that point, the user's focus would be placed at the top of the document or view, and they'd navigate forward. So with React Native and other single page app style environments, this is not the case. So what typically happens when a new view is loaded onto the screen is the focus remains on the previous activator control. So now the problem here is, one, there's no notification provided to screen readers. The user will click a control to move elsewhere on the app, resulting in no notification that anything has taken place. Focus would remain on the control they previously clicked. So this would be very confusing user experience, where the user may question the quality of the app or question themselves if they've done something wrong. And two, when the user eventually tries to move their cursor, there's no telling where it may end up. So it could be at the top of the new view. It could be someplace else. Who knows? So how do we handle managing focus between one view to the next? So there's actually quite a few different approaches you could take when managing focus between app views. One of which includes shifting focus to the view container, allowing the user to navigate forward as if a full refresh had taken place. Another one could be shifting focus to the top level heading element, allowing the user to move forward from this point. So these are a couple of potential solutions, but instead of speculating, let's review some data from a study done in 2019. So this study was conducted by Marcy Sutton, an independent web developer and accessibility subject matter expert who was working with the Gatsby team at the time. And while the study focuses on JavaScript-based single-page apps, the concept can still be applied to React Native. So the purpose of the study was to find out which approach rendered the best, most positive user experience for a number of different disability groups using various assistive technologies. So specifically, this study included sighted keyboard-only users, screen reader users, low vision Zoom users, and then voice dictation users. So all of which have unique set of requirements and expectations of what might be deemed a successful user experience. You should definitely read through this post when you have a few minutes, but I'll jump to the conclusion as to what was considered a good solution for some, but not the best necessarily for all. So basically, the TLDR version of this is to shift focus to a heading. So this was one of the more successful solutions that worked pretty well. It worked pretty well mostly for all users. So the idea is shifting focus to a heading is ideal as it provides screen reader users with a clear indication of what happened after the view loads. So it announces the heading text and focus shifts from one place to another. So for other users, voice dictation, keyboard only, and Zoom users, shifting focus to the heading orients the user to the new starting point within the app. Now, ideally, when the heading is first in focus, it would include some sort of visual indicator, such as a focus ring. Some sighted assistive technology users may have a more difficult time understanding where their cursor is without this focus ring. But it's up for the team to decide if they want to include that, which I recommend that is there. So how do we shift focus to a heading in React Native? That's actually a really good question, and one I'm afraid that I don't necessarily have a good answer for. So this is one of the issues I reported and suggested to move focus to the view heading, but the COVID Shield team at the time didn't have the time to address this one. So instead, what we can do is take a look at what the COVID Alert app does. So I took a look, and reviewing the app source code on GitHub, the Canadian Digital Services team created their own accessibility autofocus prop. So this prop is placed on the heading text component, and when the view loads, focus shifts to the heading. So for the example here, the screenshot shows the COVID Alert app running on an Android phone, and the heading text, enter your one-time key, is highlighted with a green border indicating the text has focus and is announced when the view loads. So there could be other solutions out there, perhaps a third-party component you could install and incorporate into your own project, or perhaps depending on how your project is structured, you could simply do things like using React's the ref style with the componented mount lifecycle method. That's an option, perhaps. But yeah, definitely check out the accessibility autofocus solution on GitHub, which is linked in the notes here. It actually works really well. Okay, this is the last sort of section that I have to share. So far we've discussed how to make things more accessible, how to bring context and awareness to the user on the thing they're currently interacting with. But what happens when we need to hide things from assistive technology? So this is rare, but the case did come up when testing COVID Shield, where I needed to hide a control from assistive technology. So let's explore this. So the screenshot here is a form to enter your COVID Shield ID code. And there's a single input to capture your ID, and then a button with the label Submit Code. On the left is the initial state, with a disabled submit. And on the right shows an example of data entered into the form with the submit control available for activation. Now, notice how the input is designed with the individual underlines for each digit entered. So if you think this design is unique, you'd be right. So in order to meet this design choice, the dev team had to create what I would consider a fake input. So for the code for this input is actually a box component with a stylized text component showcasing the inputted value. So sitting on top of the stylized text component is a clickable control, a touchable without feedback component. This is represented by the orange dashed outline in the screenshots here. So the idea was that on click, this control would send focus to a hidden text input control. And this control was hidden as it was styled with a width and height value of 0. So the input is represented by the little green squares here on the screen. So as a sighted user, clicking the input would bring up the keyboard, and as these are typed, they would see the content of their data being entered on the screen as they'd expect. So no problem, right? Well, not so fast. There were actually quite a few accessibility barriers created as a result of this particular design. So number one, the text input component was missing its role and name. And as we've discussed numerous times, without a role or name, the user will be missing the context and information to understand what it is they're currently interacting with. Two, the clickable component was also missing its role and name. So when this component received focus, again, no information was shared. Are we noticing a trend here? I think so. Three, due to the 0 pixel width and height of the inputs, when it did receive focus, there'd be no visible focus indicator. So this would make it seem as though there was an invisible tab stop of sorts, which in a way, without a role and name, it was. And 4, the clickable component touchable without feedback, this created another tab stop. And if someone were to activate it, it would lead to the text input, which itself had no information. So all this to say, this was a large issue, especially considering entering your COVID ID was a big part of the user experience and a core component to the app purpose. So here's what I recommended. The recommendations I made to the team to address these issues found were: 1, add the accessibility label to the text input component in order to give it an accessible name. 2, adjust the styling of the text input components to 100% width and 40 pixel height and a transparent background in order for the dashed visual to still come through. So making this adjustment allowed the input to be organically discovered by the screen reader, as the users would be either exploring or using swipe gestures to discover items on the screen. And then interesting as well, this also provided the text input's natural role to be exposed. I think because in the previous state with the 0 pixel width and height, somehow it just sort of blew away the role from being announced. So when switching up the design here, it actually allowed the role to come through. And 3, lastly, I recommended the accessibility elements hidden prop, and this is specific for iOS devices, as well the important for accessibility prop to be added. And this is one that's specific to Android. So with each of these, with their supplied values of true and no hide descendants, respectively, this hides the control from being discovered by assistive technology. So since the control really only served sighted users with the dashed visual, it didn't serve a screen reader user. So hiding the control in this way is similar to applying the area hidden attribute on a button to remove it from the accessibility tree in a browser. And as well, the tab index equals -1 value to remove it from the natural tab order in the DOM. So for the example here, the screenshot shows the COVID shield code form form, the form with the text input component highlighted. So without the recommended changes, the screen reader would basically stop on both the input and the clickable control and not announce anything. And afterwards, after the changes were made, the screen reader would provide the feedback as expected. So it would focus on the input, would announce its role and name, and thus providing the feedback required to alert the user of what they were interacting with, how to interact with it, and what to expect upon submitting the form. So time permitting, I don't know, Liam, what do you feel? Should we go to questions? I was going to demo the COVID alert app, but maybe I can skip it.
I think there's probably time to do a quick demo, Scott. Yeah.
So, okay, cool. So I'll do that. I'll bring it up here. So what I wanted to showcase was basically the idea. I'll quickly go through the app and it'll basically announce a lot of the things that I shared here today. The changes that the team made. Okay. So let's try this.
Talk back on. No exposure detected. Heading. COVID alert.
So right away, you hear that heading announcement, right? The heading was added to this particular text, and it definitely looks like a heading. So let's go down. Actually, sorry, I think my baby's crying. Let me go turn off my baby monitor. Just a second. Don't worry, my wife is with my baby, so I'm not abandoning him. So I wanted to go through and showcase a few things. So if we keep going down.
COVID alert is active. Button, menu. Double tap to activate.
So it announces the menu here, announces it with the button roll, right? So that's one of the big things that we're missing when I initially tested the COVID Shield app. So let's double click this.
COVID alert is active.
You'll notice that the focus is now on this new text, which unfortunately does not convey it as a heading. But let's keep moving.
Close button.
Close button.
Double tap to activate.
So this was one of the controls that was missing its name and role, but now it has that information available.
Button. Enter your one-time key. Button. Turn off COVID alert.
Two buttons
Double tap to
here.
activate.
I'll go to a couple more controls here. You'll notice they have like the, there's the arrow pointing up and right. Let's listen to how that is described.
Button. Get a one-time key. What to do if you're exposed. Opens in a new window. Link.
There you go.
Double tap to activate. Links available. Use swipe up then right to view.
So this was, this notifies the user that it is a link and it opens in a new context. So I'm going to try and do that now. I'll double click.
0%. Progress bar.
Right.
Pro. 70%. Web view. Double
Right.
tap to activate.
So
Double
that,
tap and hold to long press.
so this opened up the Chrome instance, the Chrome browser on my device here. So I'll go back.
Overview. But Pixel launcher. COVID alert. One of COVID alert. COVID alert.
Okay.
What to do if you're exposed. Opens in a new window.
I'm going to go back up to the form that I was
Double tap to
talking about.
activate. Button. Turn. Button. Enter your one-time key. Notify people they've been exposed. Heading.
There's a heading. That's good.
1.
Information.
Exposed people will not get any button. Next.
Good.
Enter your one-time key. Heading.
So there we are on the heading of entering the one-time key, and I'll go to the input.
Enter the key you got when you were COVID alert key. Edit box. Button. Submit key.
Oh.
COVID alert key. Edit box.
Right. So
Double tap to edit text.
when you
Double tap to
land
edit long press.
on a form
Email,
control,
Facebook, Michelle. Enter
okay,
the key you
it is announced as a edit box. That is unique to the Android device.
COVID alert key. Edit box. Button. Submit key.
I'm going to try and submit
Double
this
tap
without
to
information. I'm curious to see what happens. I actually don't know.
You need to enter your key before you can submit. Okay. Button.
Okay, that's actually
Double tap
useful.
to activate.
So there's a little alert dialog that opens up. I think that might be sort of native to the platform, but
COVID alert. Button. Submit key.
okay.
Button. Close.
So I wanted to
COVID alert
show
active.
one other thing.
Close. But what? Help. Settings.
Um,
Button. Change province or territory.
Yeah.
Button. Change language.
So this is something else that
Activate.
required
Button.
state change, the change
A
language.
hand-drawn illustration of a mobile phone in a pocket. Sending and receiving. Button.
Into the wrong
Open
thing.
alert is active. Button. Change language. Language. Heading.
So you notice that it goes to the language heading, which is great. Now, originally, there was the visual checkbox there, right? There was no state or role announcing what these things were. So if you go to them now.
Selected. Radio button. English Canada.
So there's a
Double
ton,
tap to activate.
there's a ton of information that's being shared. That's a radio button. It's in a selected state, and it also provides what the thing is by its name.
Radio button. Francais Canada.
And this
Double
one
tap to activate.
is not checked, right?
Selected. Radio
Selected.
button. English Canada. Radio button. Francais Canada.
It doesn't say unselected, but it also doesn't say selected. So here you go. Anyway, it's just a few highlights there of the benefits of doing this work and doing this testing and showcasing, to screen reader users what is actually on the screen, right? It's very helpful.
Quick question there, Scott, that just came in from Orlando, specific to the app here. Does it announce disabled buttons or does it ignore those? So if the buttons are disabled, does it announce it or does it just carry on through the page?
Good question. I don't know if there is a disabled button in this version of the app. Originally there was with COVID Shield, and when the Canadian Digital Services team took over, I think they changed that flow to have the button always be enabled. But I imagine it would say something like disabled. Actually, I think I was testing that out somewhere else at one point. But yeah, it would say disabled.
Okay, good to know.
Yeah. Cool. I think there's actually one more thing I wanted to point out, was that everything we've discussed today has mostly catered around the screen reader user experience. And while addressing issues for screen readers does help to remove some barriers for other assistive technologies, such as keyboard only and voice dictation users, it shouldn't be the only focus. So on iOS and Android, they have many other accessibility features built in. So here's a few other areas to try out the next time you're testing for accessibility. So font size, make sure your app's text is able to be dynamically adjusted according to the operating system. This helps folks with low vision be able to read content with ease. Color inversion, this also helps people with various visual impairments. So test to make sure your content is still legible when colors are inverted. And this one's neat, reduce motion. So this helps if you've got a bunch of animations on the screen. Now, some people prefer little to no animation, as they may be prone to motion sickness or other vestibular issues. So what you can do here is use the prefers reduced motion CSS media query to take advantage of this operating system setting. This is also true on desktop. So these are just a few settings available. I definitely encourage you to explore each setting and learn how you can adjust your designs to be more dynamic in order to be more inclusive for your users' needs. And I have just a bunch of resource links that I like to share with folks. A lot of these referring to the desktop accessibility experience, but again, a lot of this can be applied to a native environment as well, including React Native development. So if you have the slides there, you can definitely click through those. But yeah, that pretty much wraps it up.
That was absolutely brilliant, Scott. Thanks so much for sharing all of those insights. It was really great to see that demo, going through the UI and learn all of those cases of different aspects of accessibility, of different browsers, of different devices. It's a hugely complex topic, but it's great to see you break it down into sizable pieces there. So yeah, an amazing presentation. Thanks again, Scott.
Thank you.
We have a couple of questions here that we'll dive into. Thankfully, yeah, we've got about 15 minutes. If you do have more questions, please do throw it into the Q&A function there, and we'll try to get through as many of those as possible. So I'm going to start off with a question from Juan here, a very general question. And that is, how do we get developers to be interested in accessibility?
Yeah, that's a really good question. I mean, from my own personal experience, like I sort of shared that story earlier, is I discovered it on my own. I had my own personal interest, and from there just sort of took off, right? So I think one of the ways you could sort of help people get interested is just by running demos within your company, running demonstrations such as I did, just showing someone how to use a piece of assistive technology can be really eye-opening and can be really interesting for some folks. The other way that's also really important just in general is to test with people with disabilities, right? Run those usability test sessions and have those sessions recorded for you to share internally at your organization. It's very powerful, very inspiring to sort of take those pain points away that people experience and sort of rally to get those issues addressed.
Yeah, no, that makes a lot of sense. There's a lot of different ways of looking at it and thinking about it there. And it's definitely a space that requires as well continuous education.
Yeah, for sure. That's a big thing, is like people sometimes think this is a one and done checkbox item on their project. It's really not. It's an ongoing process, such as keeping up with latest design trends or keeping up with security issues. It's forever ongoing.
Yeah, that's great. We have a question here from Jordy. Would using a disabled property remove the need for an ARIA state, or is it good practice to provide both?
Yeah, that's a great question. So if you were to incorporate the native attribute for disabled control, you do not need to include the ARIA state specifically. The reason being that when you include ARIA, pretty much any ARIA attribute that you include, it only affects the screen reader experience, meaning that control will still be focusable. It will still be actionable. All you're really doing there is adding the announcement to that control. So in order to get the actual state of it being disabled, meaning you cannot focus on it or use it, definitely include the native, the Boolean value attribute of disabled.
Okay, good. Very good to know. Another question from Oreo. In which context is ARIA description not yet available?
Oh, yeah, that's a great question. I think it's still being in active development. Like the link I shared in the notes there has a really great breakdown of the purpose of the attribute. I don't think it's supported anywhere yet. So it's basically the same idea as applying the area described by attribute onto a thing. The difference is that area described by requires an ID value, point to something that already exists in the DOM, whereas area description it requires a string value, right? So it's the same idea as adding area label, right? Area label requires a string versus area label by includes space separated IDs. So yeah, definitely not available yet. As far as I know.
Hopefully soon.
Yeah.
I have a question here from Swapnil. How do we get current, active, or focused elements in React Native?
Okay, so I think the question is, how do we get the currently focused item? Is that the question?
Yeah, I believe so.
Yeah, that's a good question. I know that in JavaScript, there's a specific, what do you call it? It's been a long time since I've done any JavaScript work. I think it's like active element. I don't remember what it is. sorry, I don't really have a good answer for this without going into a whole lot of research myself. I'm sure it's possible. Yeah, sorry. Yeah, that's someone says, yeah, that's right, active element. So I think you can sort of you reuse a lot of the things that are available to you in the JavaScript APIs, but yeah, we'll leave it at that.
Okay.
Google it.
Yeah.
There you go.
Yeah, Oriel has just dropped a link there for
Nice.
active elements. So yeah, that should be how you can get that current element. Another question here from Jordi again. And going back to, I think it's going back to the COVID app that you were looking at. When you're changing language to French, does the voice also start speaking French?
Oh yeah, that's a great point. I should demo that.
Cool.
I believe it does. Let's try it.
Nope.
Quickly go back to that screen. Language. Okay.
Talk back on. COVID alert.
Oh.
Language. Heading. Select radio button. Francais Canada. Selected.
Actually,
Radio button.
No.
English Canada. Double
no,
tap to
that's
activate.
a great point. The answer is no. The reason is because my personal device is set up to be English language, right? So if your device was set up to be French, within French language or a French region of the world, it would announce things as French accent.
Oh, okay, that's good
Talk
to know.
back on.
Let me just confirm.
Button. Modifier Le Province au
Yeah.
Territoire.
So it's trying to,
Double tap to activate.
so it's actually trying to announce French content with an English accent, and it sounds off. So yeah.
It's good to know.
Yeah.
Elena has a question here. How do you, I think this is a really good question, and I'm not sure if there is one answer to this. How do you assess if an app is fully accessible? So like, I guess around like that sort of being able to sign off, or just to be able to evaluate that completely. And I guess like a follow-up question is like, how many people are involved in verifying that? And what's the testing process using different devices?
Yeah, that's a great question. The short answer is having something that's fully accessible or compliant is not really realistic per se. You can try real hard to get there, and there's some of the things that you can do is, like I said, tests with people have user sessions with people with disabilities, right? So there's a great organization out there called Fable, and they are an organization who do testing full time. You can reach out to them and say, hey, I'm trying to test this thing. Can you help us test it for accessibility? The other thing is to follow along the WCAG guidelines. I can't remember, did I share? Yeah, I did share WCAG. So yeah,
shared it in the chat as well.
Yeah, WCAG 2.1 AA is currently the sort of gold standard as far as meeting accessibility requirements. Now, it's worth noting that this should be taken as the baseline experience, right? In order to, and getting your app up to speed with WCAG can be quite a bit of work. There could be a lot of testers involved, with developers and designers being involved. The ideal state is to include people with disabilities from the very beginning, right? Get their inputs while things are being designed and developed. So at that point, when things roll out and you push to production, things should be in good state. You'll save yourself a lot of time and headache and heartache if you're trying to force accessibility onto a product after the fact.
Yeah, that makes a lot of sense. Of just being mindful of this as early on as possible, and testing as early as possible, and getting feedback from users with disabilities.
Yeah, a fair point. Like, as we went through COVID Shield, like I was testing as it was being developed, which is pretty good, right? Yeah. Most of the time, something will come up. There'll be a user that complains about something not being working, and then you'll have to do a bunch of testing and fixing after the fact. It's not ideal. So testing during and even earlier. Yeah.
really, really great to keep that in mind. Eldon has a question here. What do you think is the future of accessible technology?
Yeah. I don't know. It's tough to say. There's been a lot of work happening with AI over the years. But you know what? Even with those advances, even though these things are really amazing, you're always going to have that human component, right? Accessibility is by far a human issue. And like I explained earlier, it's about setting expectations for users. So I don't know. I think there's always going to be disabled people in the world. There's always going to be the requirement of testing your products. Will we get to a point where we don't need to test? Probably not. Even with the most robust design systems out there that have components that have been tested for accessibility, there comes a point where you need to put those components together, and does that user flow equal a great experience? Who knows? So you're always going to need to be testing.
Mm-hmm. Yeah, it's a very interesting point, and it does come back to those fundamentals for sure. Maybe there's a question that's slightly connected that Paul has. Is there a tool that would make testing accessibility less tedious, or are you pretty much stuck with manual testing?
That's a good question. As far as actually, yeah, okay. So there are lots of tools. I'm trying to think of React Native specifically. So there are tools that you can run while you're developing in your development environment. So there's linters that you can use. There's a couple. I believe there's one being actively developed right now by DQ. They're bringing their Axe testing suite as a plugin for VS Code as a linter. I think there's another one called WebHint, something like that. I can't remember exactly what it's called. You can add that to your development environment as well. Now, if you're developing for a website on the web, there's lots of automated tools that you can use to help sort of speed up the process. But the thing to remember is those tools can only find a limited amount of possible issues, as the split between objective and subjective testing is very wide. As far as native, I believe I meant to do some research into this. I think there might be some native apps that you can install on an iPhone or an Android device, for example, that will run testing on your app on your phone. Don't quote me on that, but I think something exists. I think there might be something from DQ as well. I'll have to look into it. But yeah, definitely lots of tools there. Definitely incorporate those into your development and design workflow. Yeah.
Great. Yeah, I've used the DQ or Axe Chrome extension, or for their inspect element style extension, which is really great. So it's good to hear that they've got plugins for text editors as well.
Yeah, it should be good.
So that's really cool. Yeah, well, we still have a few minutes for one or two. We might be able to take maybe two more questions. Here's one from Meg. How do you enter component descriptions in such a way that translations can be applied? So for example, the opens new window, so that that icon that we were looking to ensure that there is some description there that is communicated. How can we ensure that can be read in whichever language that the user's phone is set to?
There's basically a bunch of different methods that you could probably translate your app. I am not the best person to ask how that might be set up. So for my slides, like I just dropped in the raw string, but definitely in your production app, you'd want to use like a variable to hold those strings depending on the language that was set by the user. Yeah, great question. Check out the source code on GitHub for COVID alert. Everything's right there for you to review. So yay, open source.
Perfect. Yeah, no, definitely do. We've shared the the slides, there's a lot of resources there.
Nice.
Definitely dive into the notes, check out the COVID Shield source code on GitHub, as Scott mentioned. That's probably the best way to look at and to learn is to see like a working example and try and do some deconstruction yourself and just see how those different elements fit together. So that's the questions we had. Thanks so much for everyone submitting really, really great questions. Great to see audience so engaged. And thanks, Scott, for really great presentation. Obvious that there's so much insights that you have to share. So thanks for spending some time with us today. And yeah, that's all we have time for today. If you joined us yesterday as well, thanks so much for participating in these workshops. It's not over though. We still have some talks next week. I think both of them might be on Wednesday with the main React Summit conference talks. So we'll be talking about remote rendering with web workers, looking at our Argo tool for extending functionality across many different platforms, and also looking at visualizations using D3 with another talk next week as part of React Summit and Shopify's engagement with the conference. So yeah, again, thanks again so much, Scott. Thanks for everyone in the chat. Thanks for all the attendees tuning in.